Okay, we're going to go over scale factor. Yesterday we talked about how to set up scale factors in triangles, how to solve for certain sides of triangles, stuff like that. So, using letters, I'm going to set up a scale factor. Now, we discussed yesterday, I want you guys to get used to whatever angle is in a triangle, the opposite side is called the same letter, just lowercase. So what I mean by that is our B is in this corner here. So this opposite side of B is considered side B. And we represent it with the lowercase of that letter. The opposite side from C, this would be C, and the opposite side from here would be A. Okay, so instead of referring to sides by like B, C, A, B, that way we can refer to them with just one variable. Okay, and we'll do the same thing over here. We have E, F, G. Here's E, F, and G. Simple enough concept. Now, both of these are similar triangles, I'm going to tell you. In fact, what I'm going to say is that angle A is equal to angle E. Angle B is equal to angle G. And angle F is equal to angle C. That confirms that these are similar triangles. It's obvious by looking at them that the side lengths aren't the same, but our angles are the same, which means they are similar. Their ratios will work. And what we're going to work on is finding scale factor, going from the larger triangle to the smaller one and vice versa. Okay, so I will redraw those in a minute. But what we're going to do is we're going to write the two triangles and we're going to highlight them so we know which. Shouldn't have used yellow, but that's okay. So here's our larger triangle. Here's our smaller triangle. Okay, so I'm going to start with the larger triangle on top, the letters from the larger triangle. So side B corresponds to what side of the lower triangle? What would be considered its similar side? G, that's right. So we would put B over G is equal to, and we start with another letter. Let's say A. What is the similar side of A in the smaller triangle, Michael? I think it's supposed to be an E. Okay, but you're right, E. And then finally, our last one would be side C, corresponds to what? F and C. Okay, I know that gets a little confusing. This is something we did yesterday. You guys should be okay with that. If not, go over similar triangles from yesterday. So we have this information. But we also talked about, and I didn't quite show yesterday, that we could have set this scale up the opposite way. I could have said G over B is equal to E over A and is equal to F over C. There's nothing wrong with this. And what we're going to discover is that when we divide these terms, we get something called K. K represents the scale factor. So whether we divide the larger triangle, the larger triangle values on top and the smaller triangle on the bottom, or we use the larger triangle sides on the bottom and the smaller triangle sides on top, we're going to get something called a scale factor. And we represent it with the letter K. This scale factor gives us some value. And we can multiply any side on the smaller triangle or bigger one to get to the smaller or bigger one. I understand that's a little confusing. When we put the larger triangle on top, we're going to get a scale factor. We'll call it, in this case, just in this case, I'm going to call it K1. And this one K2. So when we put the larger triangle top, what that does, it gives us a value that I can take side A and multiply it by this scale factor. Whoops, backwards. I can take E, and multiply it by this scale factor to get side A. Okay? And if I do the smaller triangle on top, I can take the value of A and multiply it by the scale factor, we're calling it K2, to get the values of E. Okay, I know this is confusing, but once we use some numbers, it's going to make a lot more sense. So let's actually give some values to these two triangles here. Okay. Here's our larger triangle, here's our smaller triangle. I'm going to call this guy 5, 3, and 4. Okay, it'll be a right angle. And this one's going to be 9. Okay, so let's say we're talking about the exact same triangle before him. Here is our A, our B, and our C. And I just want to get the letters right, so it's EGF. We have E, G, F. Okay. Well, remember from our scale factors, first what I'm going to do is I'm going to show you. Both of these will work. I'm going to start with the values of the larger triangle, supposed to be yellow, the larger triangle on top, okay, and their corresponding sides. So let's set up this ratio and find out what our scale factor would be. Well, 3 and 9 would correspond to each other. So we'd have 3 divided by 9 is equal to, and this would be side E because it's opposite of E, and this would be side G, okay? 4 divided by, sorry, we're doing the smaller triangle on top. Oh my gosh. Oh my God. Do you understand that? Yes, let's pause this. How'd you get the number? Sorry. I apologize. The only thing I did here is I made this triangle larger because it didn't make sense that a side that was 3, let's say meters long, was smaller than a side that was 9. Okay, so all I do is make this larger. Everything else is the same. We're still using the smaller triangle on top divided by the larger triangle. 4 would correspond to side E. And 5 would correspond to side G. Okay? Now, instead of doing what we had done yesterday, remember yesterday we would set this up, then we cross-multiplied to solve for E, and then we did the same thing with G. I'm just going to focus on the one ratio that we do have. The one ratio that we do have is 3 over 9. I'm going to find out what that value is as a decimal. Okay? So 3 divided by 9, anyone know? 0.0333 repeated, okay? And if you look from above, what we actually found was a scale factor, K. So in other words, we're going to say that K, and we'll call it K1 in this case, is equal to 0.03. And what we mean by that, okay, is we've gotten a value, let's refer to these triangles. This being the larger triangle, and these are the values for the larger triangle. And these are the values for the smaller triangle. We've got a value, and think about this value. Because it's less than 1, we can now use this value to multiply any of the sides of the larger triangle to get to the smaller triangle. Okay? So in other words, what we've done here is I can multiply 9 by 0.33, and what will I get? I'll get 3. Okay? So if I had these other two sides, I could use them to multiply to here. But the problem is, I'm not missing sides of the smaller triangle. I'm missing sides of the larger triangle. So I'm going to flip this scale to give me a different scale factor. And I'm going to show you how the two scale factors relate. This time we're going to put the larger triangle on top. So 9 divided by 3 is equal to E divided by 4, which is equal to G divided by 5. Okay. Again, we're going to focus on the one ratio we do have, which is 9 over 3. So what's the other scale factor we're going to get?
3.
That's right. Okay. So K2 is equal to 3. That's what 9 divided by 3 is. Well, now with this, we know that we can multiply any number in the smaller triangle by 3 to get the number in the larger triangle. So with that being said, if our scale factor is 3, 5 multiplied by that scale factor 3, what is side G going to be? 15. You got it. And when I multiply 4 by 3, side E is going to be 12. That's it. A scale factor lets us go from one triangle to the other. That's all we're trying to find. Okay? Now, I'm going to show you a relationship between these two. I want this to confuse you. Scale factor 1, K1, 0 over 3, 3. How do I make this a fraction? Put it over what? 1, right? We can put any number over 1 and it's a fraction. It still works. Okay? This 0.33 is the reciprocal of our other scale factor. So if you guys remember, to find our scale factors, all we did was flip these. We had the 3, the 4, the 5 on the top, and then when we did it the other time, we put the 3, the 5, and the 4 on the bottom. We flipped them. Well, instead of actually going about doing that, I could do this a little quicker if I'd already found one scale factor. I can flip this. I'm going to show you with a calculator. 0.33, if we flip that, becomes 1 over 0.33. Does anyone know what that equals when you divide it? 3. That equals 3, which is exactly what our other scale factor was. Okay? So there's a relationship between the scale factors. They're reciprocals of each other. One of them increases size and one of them decreases size. So if you're ever confused on what the number is going to do, is this scale factor going to make me go from the small triangle to the big or the big to the small? Think of the amount. Any amount less than 1 will shrink your triangle. Okay, so 0.33 must mean we're going from the big triangle to the small triangle because it's less than 1. Anything less than 1 shrinks our numbers. Our other scale factor, 3, is greater than 1. So that must mean we're going from the smaller triangle to the larger triangle. Think about the actual amounts of these values, and it'll help you figure out which scale factor is which. Okay, so with that being said, let's write a little bit of a rule, just so you guys remember, if you're confused. If k, so our scale factor, if k is less than 1, we're shrinking in size. Okay? In other words, we're going from a large triangle to a small triangle. If your scale factor k is greater than 1, we're growing. Which means we must be going from a small triangle to the larger triangle. Okay? Those are 2 rules to help you with your scale factors. So you know when to use them. Which scale factor will be which. Because technically we could find both. Okay? Depending on how we set up our ratio.
I have the right.